Dear students, here we are having a question which is based on the electrostatics. We are continuing with the series of numericals on the electrostatics. So here I have gone through the question. Here we have an electron initially at rest falls a distance of 2.5 centimeter in an uniform electric field of magnitude 4 into 10 raised to the power 4 Newton per coulomb. The time taken by the electrons to fall this distance. Now here the question which is given to us, which is based on the electrostatic, which is on the electric field, and similarly it is on the motion also. So if we go through the question, what we have got, there is a charge which is in the form of electrons, means electron is there. Electron is having a charge that we know very well, 1.6 into 10 raised to the power minus 19 coulomb. After that, what we have, mass of electron, that is 9.11 into 10 raised to the power minus 31 kg. Now it falls from a distance 2.5 centimeters. So we have taken the distance 2.5 centimeter, we have converted it into meter. Now electric field which is known to us, that is 4 into 10 raised to the power 4 Newton per coulomb. Now it is falling from rest, so initial velocity is 0. Now when the electric field is there, means a charge is experiencing a force. So force per unit charge, this will give the electric field. Once we have got the electric field and the value of charge, we can determine the force. So force which is 4 into 10 raised to the power 4 into 1.6 into 10 raised to the power minus 19. So ultimately what we are getting the force which is acting on the electron, that is 6.4 into 10 raised to the power minus 15 Newton. Once we have got this force, now this force which is acting on the electrons, on the electron, now the electron will experience acceleration according to Newton's second law of motion. Thus this law is applicable for you. So F is equal to mass into acceleration. So simply whenever you need to calculate acceleration and if force is given to you, that force upon mass of acceleration will give you the acceleration. So acceleration is force which is 6.4 into 10 raised to the power minus 15 Newton. We have substituted the value and the mass of the electron, that is 9.11 into 10 raised to the power minus 31 kg. So when we got the value, we are getting the acceleration on electron as 0.702 into 10 raised to the power 16 meter per second square. Now once we have got the acceleration, now we need to know about the time taken to fall distance 2.5 centimeter. So here we already taken here, so we can apply the second equation of motion, means it is a combination of electrostatic as well as kinematics. Ultimately we know this equation, S is equal to ut plus half at square, S is equal to 1 upon 2 at square, because ut means u is 0 because the electron is at rest. So this value is 0, so ultimately what we are having, S is equal to 1 upon 2 at square. Now we can substitute the value of S, that is 2.5 into 10 raised to the power minus 2 meter. This 2 multiplied with this, A is here, that we have substituted here, T square. We have got this 2 point, we have calculated 5 into 10 raised to the power minus 14, 16 and 2. So 0.702. So finally we are having this value under root 7.12 into 10 raised to the power 14. So if we go through this 2.66 into 10 raised to the power minus 7 second. Here if we go through the answer, 2.4, 2.1, 2.6 and 3.6. So correct answer is this. So by observing the question first, we come to understand what are the given in it, and once we go through it and if we know the parameters of the questions, we can determine the answer. So this way we can solve the numericals, and thus by solving the numericals we can opt for the MCQs also. This way we can go for the MCQs. It will helpful for you in preparing for the competitive examinations.